A newspaper has 9 reporters available to cover 4 different stories. How many ways can the reporters be assigned to cover the stories? The key word here is it says different stories. To me, that means that the newspaper boss has specific stories he wants covered. If he would have said, the newspaper has 9 reporters available and 4 people need to work today. That, to me, is not assigning specific stories to reporters. Okay, that's different. But in this case, it seems to me they have 4 specific stories to assign to reporters. So this is a permutation. So when you have a permutation where order matters, you're going to use the permutation button on your calculator in the probability menu, which is 9P4. 9 choosing 4 is what people say. 9 choose 4. Permutation, which should be 3024. If it would have said, like I said, if it was just say 9 reporters, 4 need to work today. 4 need to go cover the plane crash. Order doesn't matter. 4 people are going to cover the plane crash. That's a combination. We'll get to those in a second. All right. Something different. And this is a formula that you need to know because this is not one button on the calculator. If you're doing something where there are objects that are alike, you have to account for that by dividing by them. So the number of permutations of n objects of which p are alike and q are alike, and there could be more, is the total factorial, which is part of your probability menu as well, the factorial button, divided by p factorial, q factorial, and more if there's more. So if you're taking balls out of a bucket in a specific order and some of the balls are identical and you can't tell which one you took out, taking a red ball out is taking a red ball out regardless of which red ball you took out. Those are some identical objects. So you're not going to have as many combinations then. It's because you have identical objects. Here's an example. How many different ways can the letters of the word Mississippi be arranged? So what we're going to do is on top, we're going to take the total number of letters, which is 11, and we're going to divide that by the twinsies. The letters that occur more than once. If there are no letters that occur more than once, you just have 11 factorial. Okay? So what we have is, on the bottom, and this would have to go in parentheses if you're doing this on a calculator, we have 4 factorial for S. We have 4 factorial for I. And we have 2 factorial for P. All the twinsies need to go in the denominator. Anything that occurs more than once. Because if you switch the 2 P's of Mississippi, that doesn't count as a different arrangement. That's the same thing. So you have to divide those different arrangements that are the same arrangements, is basically what I'm saying. So you have to do that on the calculator and you have to do it correct. Try to do that on your calculator and then I'll show you what the answer should be in a minute. If you did it correct on your calculator, you should have gotten 34,650. If you did not put it in your calculator using the parentheses, or if you did not find the exclamation point or whatever, then you probably missed it. Does anybody not know why they could not get that on their calculator? Okay, good. You try this one all by yourself. Correct setup is 7 factorial over 3 and 2, giving you an answer of 420. Yippee skippy? All right. Combinations, the order does not matter. The way I remember this is Combinations are like a committee. Starts with a C. Or a club. You can be in the science club and you're just a group of people in a club. The order that you sit in, just a group of people. Order does not matter. I think of permutation as like president. All right, the officers of a club, there's a specific order to that. So that's how I remember it. Combination, committee, club, it's just a group of people. Permutation, president, there's a specific order or hierarchy to the objects. Okay, so in a combination, order does not matter. It's a different formula. On your calculator, it's a different selection. And you should have seen it. It's right by NPR on your probability menu. Did you find them on yours?
I don't think I have them.
Oh, yeah, you do. I'll be able to find them here in a second. A group of 7 students working on a project needs to choose 2 students to present the group's report. It doesn't say one person needs to talk and one person needs to hold the poster. That would be a permutation because you're assigning different things. It just says 2 people need to present. So that's a committee of 2. So in this case, where order doesn't matter, you just got 2 people. Combination. And now that we have both of them, it makes it a little more difficult because you have to decide, is this a permutation or a combination? So you do combination 7-2, which should be 21. A family with septuplets assigns different chores to the children each week. How many ways can 3 children be chosen to help with the laundry? Laundry takes 3 people in the land of septuplets. They did not assign specific laundry jobs to the septuplets. They just said, you 3 need to go help with the laundry. So is this a permutation or a combination?
Septa 6.
It's 7, I believe. Permutation or combination? Combination because it's just a group of 3 kids. They didn't say anything about you do dirty, you do clean, you do all the ironing. So combination 7-3, which is 35.
Wait, combination.
The manager of a 4-screen movie theater is deciding which of 12 available movies to show. The screens are in a room with different seating capacities. How many ways can she show 4 different movies on the screens? In this one, we have 6 factorial over 2 factorial, 2 factorial, 2 factorial for the twinsies, which is 720 divided by 8, so the answer would be 90. In the first one, notice how they say in the directions each one is unique. So make sure you're looking at that when you're looking at the problems. She wants to know how many ways she can order her meteorites. And then in the bottom, she wants to trade 3 of them away. How many ways can she pick out 3 meteorites from her collection? Do both of those questions. Okay, in the first one, I would do 7p7 like we did our single file line. And get an answer of 5,040. You agree? Yep. Okay, now in the second one, I see a combination. Because she's going to pick 3 meteorites, put them in a box, and send them away. Does it matter if she picks white, red, black, or red, black, white, and put them in a box?
That's what she's trying to find out.
She's going to trade away 3 meteorites. She's going to give 3 away. Does it matter what order she picks those 3 and sends them off? It really doesn't. So I would call that a combination, which would be 35.
Strong.
What? Okay. So I asked you to do 17, 18, and 20. Here are the ways that you do all of these. For 17, you should have chosen 10p3, whatever that is. What is it? 720. For 18, you should have chosen 7c4, 35. And then for 20, it was just 7 factorial over nothing, because there were no twinsies, which is 350,000. What is it? Huh? Oh, just 5,040? Sorry, I was way off. 7 factorial.